Hi everyone, this video is on exercise 11a of Pure 2, and in this video I'm going to do question 1 parts A and B. So this exercise is all about standard intervals, which means there are some certain integrals that we just need to sort of memorize and just know how to use them, because the thing about integration is that it's not like differentiation, because in differentiation you sort of have more freedom in terms of that you just learn some general methods and then you keep applying them. Still, that doesn't mean differentiation is perfect and those methods are going to be useful all the time, but they're at least kind of more useful than integration, because in integration it's much harder, and so that sometimes we need to learn some standard intervals. Of course, we are going to learn some techniques in the next few chapters, but we still need to learn some standard results. So just quickly mentioning these results, the first one is what we had in pure 1. So if you have a polynomial or kx to the power of n, you essentially add 1 to the power, and then you just divide the basically the expression or the term by the power. This k is just a constant, by the way. So x is the variable, k is a constant, n is also the power. So in this case, n is also a constant. The second one is just for exponential functions. When we have e to the power of kx, again k is a constant, maybe e to the power of 2x, then we have 1 over k times e to the kx. So as I will solve these examples, you'll see how I apply these. But the best way of getting comfortable with these standard integrals is just using them by solving questions. And the next one is when you have 1 over kx. So this is equal to 1 over k ln x plus c. And this is also equivalent to ln kx. So if you see this form, this is basically the same thing, but I think this form is more common. And then integral of cos kx is 1 over k sine kx, and then we have for sine. And then integral of sec squared kx is 1 over k tan kx. And then we have cosec kx times cot kx, which is minus 1 over k cosec kx plus c. And then we have two more, so cosec squared, which is cot minus cot, and then sec times tan is sec. So it was just a quick way of showing this, but now I just want to use this. So in part A, we want to integrate 3 sec squared x plus 5 over x plus 2 over x squared. So remember that the first thing that I want to say, 3 sec squared is just one of the standard results, right? So sec squared kx, in this case, k is 1, by the way, because x doesn't have the coefficient of x is just 1, right? So k is 1 in this case, so we ignore k from the formulas. But so we have 3 sec squared x, and essentially we can see that sec squared integrates to tan x. So in this case, when we have 3 sec squared x, basically we have 3 tan x. So sec squared x integrates to tan x, and 3 is just a constant that it just stays, doesn't change here for this question. Now the next term is interesting because we have 5 over x, and you might be saying, okay, it becomes 5x to the power of minus 1, which is correct. And then if you want to integrate by using the pure 1 technique, then we would add 1 to the power and then divide that by the coefficient. But the problem is that if we add 1, minus 1 plus 1 is 0, and we cannot have 5 divided by 0 and then x to the power of 0, because this is just undefined. So the only case that this rule doesn't work is when you have 5 over x or anything over x, and that's when you use len. So in this case, 5 over x is basically the third case. So in this case, we have, again, x in this question doesn't have a coefficient, so we can ignore k. But it just integrates to len x. So obviously, since we have 5, it will become 5 len x. And finally, 2 over x squared. This is something that we have done a lot of times in pure 1. So 2 over x squared is the same as 2x to the power of minus 2, and then we just add 1 to the power. and divide 2 by that. So 2 divided by minus 1, x to the power of minus 1, which is minus 2 over x. And finally, the constant of integration. And yeah, so this is the integral to this one. Okay, so for part B, we have 5e to the power of x. So minus 4 sine x plus 2x cubed. Again, e to the x just integrates to e to the x. So in this case, I have included k just for the cases that you have also a constant, but we don't have that here. So e to the x just integrates to e to the x. So in this case, you have 5e to the x. So that integrates to 5e to the x. It basically doesn't change in this case. And you have minus 4 sine x. So remember that sine x itself integrates to cos x. Sorry, sine x integrates to minus cos x. And then minus cos x times minus 4 becomes positive 4 cos x. And finally, 2x cubed is just, again, pure 1 stuff. So we have 3 plus 1, which is 4. 2 divided by 4 is a half. And then x to the power of 4. So this is the answer here. And as you can see, these are very different to what we had in pure. So it's just a combination of pretty much everything, every sort of function that you have seen so far. Yeah, so as you practice these will become easier, but it takes a bit of time. So be patient with these integrals.